Hello, everyone. My name's Mackenzie. I am a product manager here at Fermion, and I'm excited to have Caleb on today. I'll let him introduce himself.
Hi, everybody. My name's Caleb, and I'm a software engineer at Fermion. Excited to be here.
Yes, and this is Live Coding Tuesday, where we dive into relevant topics about all things spin and WebAssembly. So today we have a fun topic, something we've been working on, and Caleb specifically at Fermion, and that is observability. Prior to being at Fermion, Caleb, I'm curious, did you work with observability tooling in the past, or was this kind of your introduction into the space?
That's actually such a great question. No, I had not touched observability before. And I learned a little bit about observability, kind of using it internally in my, here at Fermion. But it's been fun to like dive in and learn about observability a bit more and Otel a bit more as I've worked on these features.
So we're all excited to learn more today. And yeah, actually, we both took an intro to Datadog here at Fermion and got familiar with that. So.
Yes, yeah.
Oh, man, good stuff. All right, well, we have a few slides prepared, but don't worry, it's Live Coding Tuesday, so there's a demo. Caleb's going to be breaking open VS Code, and we'll be walking through some of this live. But to start off with, we wanted to set some context. Screen is up, and if you're tuning in, definitely say hello in the chat. We'd love to hear from you, where you're tuning in from. And given the topic for today is observability, if you have any questions or tools that you like to use, go ahead and throw them in the chat. All right. So, context setting. We've talked about this quite a bit in live streaming sessions and blogs, all of this good stuff, but the evolution of cloud computing and the waves from the virtualization of like VMs and moving code from on-prem to clouds to containerizing applications and this nice packaging mechanism that made them more portable than they had been historically, to a serverless paradigm where we're separating out the server from our business logic and running code only when it needs to be run, and allowing the platform team to take care of the rest. And more context, you rarely use serverless applications on their own, right? They typically have other resources like object storage, pub subs. On Fermion Cloud, you can make, or with Spin in general, you can make inferencing calls to remote models. And so there's a lot of different pieces that are all coming together to deliver an end-to-end workload. Once you have that running, right, like odds are it's not going to work perfectly 100% of the time. I mean, that's an ideal state, but oftentimes things will go wrong, right? And we need to understand, once we have our application up and running, why is this behavior occurring? Short answer to that is observability. We have metrics, logs, and traces all available, and Caleb's going to go into more detail today. But these are all clues to help us understand what's going on with our application. And there are a lot of tools out there to help us pull those resources from our application, store them, look into it in an efficient way. And this is just a really quick snapshot of the CNCF landscape for observability-centric projects. But a lot of them have been written for containerized workloads. So the question we have today with Live Coding Tuesday, a stream that focuses mostly on WebAssembly, is, do these tools that I know and I've used all the time with my containerized workloads just work with my Spin application? And the answer to that is we're working on it. We had an exciting advancement with the release of Spin 2.4, where we have experimental support for OpenTelemetry, or Otel for short. And Caleb's going to be talking a little bit about what went into that and how you can get started with that today with Spin 2.4.
Absolutely. Happy to talk a bit about Otel. I want to do this live for a second, go off on a bit of a tangent, talking about using all those kind of day two observability tools. I think one of the things that I'm so excited about for SpinCube is that we get to like integrate into this Kubernetes ecosystem and use your WebAssembly apps alongside all of this kind of like cloud native tooling you're used to. And so there's like a little bit of integration work to do, but you get so much out of the box just by kind of supporting that Kubernetes ecosystem. Anyways, that's just really exciting to me. Little exciting tangent over there. Okay, so Otel, a number of people here might be familiar with this already, but we're just going to do kind of like a little primer on what's going on here, so people have context set for the demo we do today. And so Open Telemetry, OTel, it's kind of an abbreviation of that, is a vendor-neutral open source observability framework. And that's like a lot of terms, but if you break it down, it's not too bad. So observability is really just, how do we take like a system we're running in production and understand the internal state of that system so you can debug it and kind of like figure out what's going on while it's running. So that's what observability is. And so OTel is a framework to help you do that. Typically, you're going to be doing that through a number of different telemetry signals, is what they're called. And so Otel supports 3 of those: traces, metrics, and then kind of has preliminary support for logs, but that's still falling into place with the specification. So we'll talk more about what each of those signals means. But Otel is really kind of, this term vendor neutral open source framework around that. So it's great, it's open source, but it's become this kind of like industry standard. Before Open Telemetry, there's a number, I forget the names of them, it was like Open Census and something else, and all these different competing standards on how to do telemetry, and all the backends like Datadog and stuff had different formats, and it was kind of just this mess of, making it really hard to observe your apps. But this standard is now supported across many languages and many backends, and really kind of has standardized the community around it, which is really exciting.
Yeah.
Oh, go ahead. Yes.
I was going to say, I feel like the portability of this is what really like piques my interest, because observability can be pricey, right? Like storing a long history of logs, metrics, and being able to standardize how you're collecting and exporting them just helps remove some of that gravity and makes it a little bit easier to send that data where you want.
I love that. That's the perfect segue too. So Open Telemetry, this diagram we have here is like the perfect diagram to explain it. It's almost like it came from their docs and they thought really hard about how to make a good diagram to explain their stuff. Open Telemetry is kind of responsible for like everything on the left-hand side of that diagram. I guess maybe I need to move my hand to the right. I don't know how mirroring of video cameras works for all my hand waving. And so, imagine you have like a bunch of microservices in your architecture running, and that's running on a bunch of infrastructure, maybe directly on VMs or Kubernetes or on a serverless platform or whatever. And you want to kind of emit this telemetry signals from this. You want to have traces and metrics and logs about all these things. So for your microservices, there's a number of different things Otel supports to it's called instrumenting your applications. You can auto instrument your app, which basically like automatically traces all the functions and sets up all that automatically for you, which is great, but sometimes doesn't quite do it like you might want to. So in that case, you can directly, integrate with the API, or you can use SDKs that different languages support. And then a lot of the infrastructure just kind of supports out of the box shipping signals. And so then all of these signals are coming out of these applications, out of your infra, all these different places, and you feed them into the collector, which is kind of the heart of the Open Telemetry project. It's this like process that you can run, and you run it in your infrastructure, or you can run like a managed version. And then this collector is like what does the magic of collecting all this data from disparate places and then shuttling it off to different backends. So maybe you're sending your traces off to Jaeger, the Jaeger instance you have, and you're sending your metrics and logs off to Datadog, and all those kind of different things. And you just configure that with a simple piece of config in the collector. I'll pause. Any comments, Kenzie? Any questions from the crowd?
No questions from the crowd yet, but putting on my like application developer versus platform engineer hat, it sounds like as an application developer, I'm responsible for instrumenting basically either the SDK or like setting up auto instrumentation to pull these logs and traces from my code. And a platform engineer is going to be responsible for like running this collector and connecting it to the observability front ends and APIs. Is that
Totally.
a fair way to think about it?
That's a great way to put it. I love it.
Great.
Cool. Well, maybe we can go on to the next slide here.
You got it.
So we're going to spend a little bit of time diving into the documentation just to learn 2 concepts a little bit better. I'm doing the dual monitor dance here, so I'll be looking to the left now. Don't get confused. I'm not distracted. I'm not looking at Slack or something. But so we're going to talk about 2 things. We're going to talk about what is distributed tracing, and then we're going to kind of understand what is context propagation. So I'll share my screen. We'll look at the docs and do that, and then we'll come back here, kind of understand the app we're going to do, and go through a demo for that. Now, the reason we're kind of focusing in on distributed tracing is because with our experimental support for Otel in Spin, we're currently only supporting tracing. So we don't have support for metrics yet or logs, and we'll be talking more about that later. Let me just figure out how to share my screen here. I want to share a window, and I want to share this one. Awesome. Nice. Can we see my docs?
Now we can.
Perfect. Okay. So we've already talked a bit about what is observability. Just kind of hitting the point on these three signals again. Logs are what you expect logs to be. Logs are just log statements coming out of your application, and they were great and they're super common, but they have some weaknesses. It's hard to associate them with specific parts of your code base and specific moments in time. And so kind of, this concept of a span or trace arises to kind of solve some of those problems. And so a span or a trace, well, I should use the term span, is really kind of just representing an operation of work, a unit of work. So maybe a function call, or handling a request, or a client making a call, or an inference in a database. Those are all examples of, units of work. And so the span is like tracking how long did that take? What's the duration? And then additionally, you can add all this kind of metadata to it. And this metadata is just like additional things about that unit of work. I just also want to add, I don't think they have it on this slide, but metrics are what you would expect metrics to be. So maybe it's like a request count, or like a histogram of like the average request duration, or things like that. But we won't be focusing on metrics today. So spans, they're great. Here's kind of an example of what a span looks like. You have a client making a call, and that client's making a call to an API, et cetera, and it kind of keeps making these calls down. But spans are only like so useful, especially once you start to have these kind of like distributed architectures where you have one service calling another service that's calling a database, and it's going all over the place. What you really want is to be able to trace your path through all of these spans and kind of have what you call a distributed trace. And so a distributed trace is really just when you kind of like track the requests made through your system. So the client calls the API, and the API calls the authentication service, et cetera, even if this is across different services in your architecture. And that just makes it really easy to kind of be able to debug and understand requests made against your architecture. I'm going to move on to context propagation in a second. We'll understand how you actually get these distributed traces. But pausing, any comments, questions, or should we keep going on?
This all makes sense, and I can see the power of this, especially when you're working in a multi-service or microservice architecture, and being able to understand exactly what step is taking what amount of time and maybe where the error is occurring. Definitely a useful tool to have. So I'm excited to learn a little bit more about how we're going to integrate that with Spin.
Totally. Well, and you asked the question of like, had I worked with Otel before? And so I hadn't, but we started using it for internal projects here at Fermion, and it was kind of this like before and after moment for me where I was like, what are these spans? This seems like so much work to trace all my code. I don't like this. And then when I started debugging with it, I was like, oh my gosh, how did I ever like work before I had all this tracing information? This is so much nicer than just like console.log printing and hoping that I like understand what's going on in my code base. So it's really handy.
Yep. Looking at the timestamps and just hoping you get it all right.
Yeah, exactly. Dead reckoning. Okay, so context propagation. Context propagation is this concept of we have these telemetry signals. Remember, that's traces, logs, metrics, and we want to like link them together across different services. So, for example, you have like your client, it's making a request to your server, and they're both emitting a span of like, the client's emitting a span of like how long does it take to do the request, and the server is emitting a span of like how long does it take to handle that request. You want to link those two signals together. And so you do that by context propagation. And so let's break down the two parts. Context is like the information representing which like global trace ID you should associate this with. So really in practice, it's just this string that's like trace ID 1, associate this with trace ID 1. And so you want to then propagate that context between services so that it knows when it's emitting a span, which trace to associate that with. So let's be visual about this for a second. When this client is making a request to this server, it's making an HTTP request, and it's going to propagate in the header of that request the trace ID that should be associated with it. And so this API, the server is going to receive that. It's going to parse the context out of the header, and it's going to use that as like the parent trace ID for the span emitted from the server. And then when both the server emit out the span to the collector and the client emits out the span to the collector, they both have the same trace ID. And then in the collector, it's going to do some magic and know, hey, these are all from the same thing. I should link them together in this distributed trace. Bit of a interesting concept, maybe a little bit confusing for the first time. So I'll pause for questions, but we'll see more examples of this in the demo.
Yes, definitely throw in your questions in the chat. We're happy to address them. One I have top of mind while people are thinking is, like, how do you go about just defining the boundaries of a context? Like, is there a best practice, or is it just up to the application developer to decide what's going to fit within a particular context versus creating separate ones?
Yeah, that's a really good question. I guess the answer is it sort of just automatically works out from Otel. So like when you let's imagine this client is one process, and let's imagine like this is one server. All this API stuff is living in one server. When this, you start the span in the root of the client here, and this, because the term is a root span, it's like the first span, it automatically gets like this trace context. And then you propagate this in the request to the server, and it picks it up. And then it's just going to kind of propagate that trace context to the children. And so you're not like really necessarily choosing the boundaries of the context so much as just propagating it all the points. It goes to different processes or services. And I guess as I say that out loud, you can make choices. So for example, you might want to not propagate it to a certain service that you don't care about tracing. That's an example of you kind of choosing the boundaries of this context. But for the most part, it kind of just works out of the box.
Yeah, that makes sense. So you're starting from basically the starting point, and every single piece service that needs to touch in order to achieve its goal will likely get that trace unless you've decided to keep it off for whatever reason,
right,
or omit it.
Right. Okay, should we hop back to the slides here?
Yeah, let's give it a shot. All right, it's a fun game of finding the right screen to share. So
yeah, relatable.
Hang with us. Let's see. So you talked a little bit about how we have traces and metrics and logs. It sounds like those are on the roadmap.
Yes. So traces are largely supported in Spin 2.4, and we've got a bunch of improvements to the tracing done in Spin coming in 2.5. It was really kind of like super preliminary stuff in 2.4, and so 2.5 is going to clean that up a bit. And then we might be talking more about this later, but we've got stuff coming down the road of like metrics and a number of other things we want to support.
And then I guess a point I wanted to call out earlier too is when we're talking about logs, we're talking about application logs as opposed to, I'm assuming like if you're running on a serverless platform, right, there could be platform logs that are being emitted, but those would be tracked in a separate manner.
Yes, likely. Theoretically, you could imagine your platform supports you receiving those logs in your collector, so you could associate that, but likely it would be different.
All right, well, back to the regular scheduled program. We've done an overview on Otel, and now we get to join that with Spin. So what sort of application are we going to be looking at today?
All right, so today we're going to be looking at sentiment analyzer. Can't say a word.
It's a tongue twister.
Yeah, it is. Sentiment Analyzer, our favorite app here at Fermyon. And so Sentiment Analyzer is just kind of this fun little demo app we have that uses our LLMs to do sentiment analysis. So it's kind of like a chat platform. You can send a message to it, and then it will analyze the sentiment of that message and say, hey, this is a positive sentiment or a negative sentiment or a neutral sentiment. Kind of just a brief, I guess, description of the architecture. We've got our Spin app here, and it's got 3 components in it. It's got an API component, a UI component, and a KV Explorer component. So kind of let's start with the UI. The UI is going to be serving up that beautiful UI you see to the left there. And when messages are sent, requests are going to be made against the API component. And so then that API component is going to receive a message of, hey, do sentiment analysis on this sentence. First, it's going to check in the KV to see if we have a cached response so that we can avoid the effort of calling the LLM. And then if that's not there, it's going to call the LLM. It's going to generate a response, store that in the KV, and return that back to the UI. And then the KV Explorer is just kind of a convenient component to be able to see the keys in your KV.
That is great. We do actually have one question that's come up that we might take a brief pause to answer. So Adis, and apologies if I didn't get the pronunciation quite right, wants to know if there is eBPF-based tracing available for spin workloads.
The short answer to that is no, I think. I'm not super familiar with eBPF, to be honest. And correct me if I'm wrong, Adis, or I'm sorry if I mispronounced that, but eBPF would be separate from Otel. Like there's not a concept of eBPF tracing baked into OpenTelemetry. And if there is, please correct me in the chat. I'd love to learn about that. But yeah, currently we don't have support out of the box for that kind of tracing.
All right. Back to sentiment analysis. So that high-level overview makes sense. We have a key value store, we have a way to observe it, and we're calling out to an LLM to assess whether or not the sentiment is positive, neutral, or negative.
Totally.
All right. And you can also check this out. I think it's worth a pause here on SpinUp Hub as well, which is our one-stop shop for all of our example applications. So you can check this out. We've recently also uploaded a bunch of enterprise architectures and patterns, which we're really excited about, that work with Fermion Cloud, SpinCube, all that good stuff. So definitely check those out as well.
Awesome. Okay, we're going to spend a little time just kind of looking at the business logic of this app. I think that's helpful context here. So perform sentiment analysis is really kind of the heart of this program. We're taking in a request and we're going to parse out that sentence. And then, like I said, we're going to be opening up a KV store. We're going to check, hey, do we already have like a cached sentiment for this sentence so that we can avoid the potentially expensive call to the LLM? If we do, we'll just return that. And then otherwise, I think if we go to the next slide here, we are going to run the inference. So we'll build our inference options. We want to limit the max number of tokens coming from the model because we're looking for like positive, negative, or neutral. That's not a very, like, that's probably like 2 or 3 tokens. So we don't want it to spit out a response that's like, hey, this is a very positive sentiment that this sentence has. And then we're going to be calling the LLM using the really handy SDK from the JavaScript, the Fermion TypeScript SDK. And we're passing, want to use the Llama 2 chat model. We're passing in a prompt, which we have off screen here, and then the options we configured. And then, we'll parse out the sentiment and cache that and then return that back to the user.
One of the things, not totally related to observability, but I think just where Spin is really nice to use as application developers, you're not really concerned about what's backing that key value store. And as we test things out locally, we don't even have to worry about setting up a key value store. It's all handled for you by Spin, and you just worry about implementing this basic logic of checking if something's in your cache, and if not, adding it. And same with the LLM. So I just think it's really a clean way of writing this kind of app.
Totally. I mean, that's huge with the LLM, like being able to run it locally by just downloading a model into the right folder. Use like trying to use one of these models not through our SDK is a lot of work. You got to make sure it's running in the right spot and write a bunch of custom code and make sure you got the GPU set up. It's a beautiful abstraction.
And to be honest, I'm usually too lazy to download the model when I'm using these kind of apps. I just use our cloud plugin to access the GPUs on Fermion Cloud because.
Do you want to talk about that for a second, maybe?
Yeah, of course. Don't have a slide to talk about it, but on SpinUp Hub you can access this as well. But we have a Spin Cloud GPU plugin, which essentially allows you to run your application locally. And when you apply this plugin, we're actually spinning up a proxy in Fermion Cloud that will make inferencing requests on your behalf for that local app. So it's a really clean way. You simply add a little bit of context to your runtime config, and you're able to get your responses much quicker than you would on your local machine, especially if you're not rocking a GPU locally. So it's really easy to get started, and I'll find that link for anyone who might be curious about trying that out themselves.
I just put it in our private chat. Perfect. And I also put the link to the sentiment analysis app in there you might want to share.
Great.
Go ahead.
And last question, I'm curious, since we've explored this app quite a bit, what was the inspiration behind building this? Because I know this was just a sample app you put together. What was your thought process when you were building this?
I don't know if I should share this. This is really going to make it the allure of this app less exciting. The inspiration was Radu saying, "Hey, you should make a sentiment analysis app." Yeah.
Okay, because I know you had I know you have a personal blog and that sort of thing. So I was curious if you're just trying to augment that and analyze the feedback you might be getting. But
No, yeah, well, a little plug for calebshep.com. No, yeah, I just wanted to kick the tires of the LLM stuff. We were right in the kind of middle of shipping it. It was a super exciting time, and I wasn't working on it. I was like, I'm going to take a day and go around and play with this. So, just for fun.
awesome. Well, and if you're feeling inspired, we love community contributions on SpinUp Hub as well. So if you feel like you can build upon this, or this gets you inspired to build a kind of similar style app, checking out these different capabilities within Spin, we'd always love to see it.
Absolutely. Okay, great. So now we're looking at the spin.toml, which is the manifest describing our Spin application here. And kind of the main thing we wanted to point out is this kind of like configuring of capabilities-based security, which is me throwing some exciting WASM terminology into here. But really what that means is that when you're using WebAssembly, you need to explicitly request access to the resources that you want to use for security purposes. So by default, our app is not allowed to make any outbound calls to any other applications. And we also aren't by default allowed to use any AI models. And so, but here in the manifest, we're able to specify, hey, we want to explicitly have access to this Llama 2 chat model and configure any outbound hosts that we want to support.
Yep, all good stuff. And actually recently on Fermion Cloud as well, we've added support for something called links and labels. So if you deploy this application and for whatever reason you wanted to upgrade your key value store, or perhaps you wanted to add a different prompt in that key value store that's going to be pulled by that application, you can simply swap it out without having to recompile or redeploy your application, which I think is another cool capability we get here. These are just labels that are referenced by the application, but they don't actually tie to a specific implementation for any of these resources. So really easy to swap supporting pieces of infrastructure in and out in order to meet your needs.
Totally.
All right, so let's take a look at this app.
Demo time. Okay. I will share my screen again.
By the end of the stream, we're going to be pros at switching contexts. No pun intended.
I want to share this little screen. Okay. Bring some code over there. Great. So I am running the sentiment analysis TypeScript app. We were looking at this earlier. So here it is. And basically the demo we're going to be doing is we're going to run the sentiment analysis app locally. And then we're going to be calling into a cloud GPU app, which is that project Kenzie was talking about. And so instead of running that in the cloud, though, we're going to be running that app locally. And so basically we have one spin app calling into another spin app that's going to be doing the inferences for us under the hood. And the reason is because currently we don't support in Fermion Cloud the emitting of spans. We plan to support that in the future, but this is still experimental support. So we're just going to show it locally. And then we're just going to kind of show a couple variations on this of like making a request from a client, showing what it looks like cached or errored, that kind of stuff.
And while we're on the topic of GPUs, another interesting question is, could we use the Cloud GPU plugin to leverage like cloud agnostic support, so tie into other cloud providers?
That's a good question. I would say out of the box, the way Cloud GPU works, no. Well, because all the Cloud GPU really is here is like literally just a spin app that does the inferences and just parses HTTP requests that come into it and say, hey, do this inference for me. So you get like multi-cloud in the sense that anywhere you can run a spin app, you could run Cloud GPU. You could run that Cloud GPU in SpinCube. You could run it in Fermion Cloud. You could run it on like your own Fermion platform hosted thing you have set up. So yes, multi-cloud in that way, not cloud agnostic in the way that like it's automatically hooking up to a GPU in any like AWS or anything like that.
Yep. And yeah, not being bypassed by SpinCube to put the second half of this question, but you certainly can like run this type of workload with SpinCube. I actually think Kate, who's an engineer at Fermion, was working on moving this application over to SpinCube and having the inferencing calls happen on the cluster as well. So that's certainly a possibility as well.
Totally. Okay, let me just bring my terminal over here too. Whoa. Okay, and I'm in the right TMUX session. Perfect. So we've got 3 apps going on here. First, we're going to run the sentiment analysis app locally. So this is a mouthful. I apologize for the really long command here, but we'll break it down. So we're running spin up, and we're going to be listening on a different port, 3001, because we want the other cloud GPU instance of spin to be listening on 3000. And then we're just passing it a runtime config file, which I will show. So our runtime config file is just saying, hey, for any LLM compute that you're doing, use the remote HTTP implementation, and you're going to be going to localhost 3000, which is the other spin app I'll be running in a second, and use the auth token foobar.
Hey, do you mind just increasing the font size just a little bit?
Great point. Thanks for pointing that out. Let me do that in code 2.
Perfect.
Zoom. I guess I can just do this. Right, and so, what this means is, where is it? LLM.infer. When we're doing this, it's going to be using the remote HTTP. So instead of directly in this spin app using the model, we're going to be calling out to another application somewhere that's doing the inference for us. Okay, so then all of this stuff in the front is just this KV Explorer user and password is just setting the user and password to connect to the KV Explorer, so we can kind of ignore that. But then this is the important part. Otel Exporter.
Sorry to cut you off, but before diving into that, just a quick aside, if you're not familiar, KV Explorer is just an observability component that we've built to let you peek into the contents of your key value store. And obviously, you don't want that publicly accessible, so it is password protected. But yeah, a nice way for you to just take a look at what's going on. Works locally, it works when you deploy your app to Fermion Cloud or SpinCube.
Exactly. So here's just the key value explorer. Great point, Kenzie. Okay, so this Otel Exporter OTLP endpoint, this is how we configure where we want to send our telemetry data from Spin to. And so we're configuring, hey, this is like the Otel Exporter endpoint that you should send it to. And this tells Spin to turn it on. By default, we're not going to be sending anywhere unless you give us an endpoint to send it to. So we're just saying localhost 4318. I guess just for context, I have just Jaeger running locally in Docker. I've exposed a couple ports, and it's just Jaeger running. This command is in our documentation on observability if you're following along.
Great. And for those who may not be familiar, Jaeger is...
Great question. That's a fantastic question. So the Otel Exporter was allowed you to send to a number of different backends, and Jaeger is a backend that supports tracing. Doesn't support metrics or logs, but it supports tracing. But Jaeger also has the ability to kind of just ignore the Otel collector in the middle, and you can just send directly to Jaeger. So it's just kind of a simpler, easier way to be able to see our traces. And I can just give a quick little show of what that looks like here. So here's Jaeger, and it allows you to see your traces. And we'll see more of this in a second.
Nice, much cleaner to view that way.
Yeah. Great. So we'll get this app running. Is this the right one? Yes. I don't know why the command was cut off, but that seemed to run fine. Now we're going to run this other app. And so this other app is running the Cloud GPU app. And so we're saying, hey, use the foobar auth token, which we set in the runtime config in the other place. Is this zoomed in too?
A little bit more, if possible.
Let's try that. How's that?
Better. Yes.
Perfect.
Thank you.
So we're also going to be configuring the exporter endpoint. So this is also going to be sending trace data to the same collector, and we'll just run this app.
While it's running, another question. So previously we were exploring the application manifest where we're connecting to our LLM, our key value store. You mentioned the term runtime configuration. Quick synopsis on what that file is and why it's important to a Spin user.
Great question. Runtime config is basically allowing you to configure anything you want to configure at, wait for this one, runtime. So there's a bunch of examples. You can, configure different compute providers for your LLM, or different variable providers for your Spin variables, like the environment or Vault or things like that. I don't know. You should drop a link to the documentation. I can't think of all the examples, but it's all these kind of things that you don't want to make a decision about until runtime of your Spin app. What sort of backend implementation you want to use.
Yep, that makes total sense. And definitely not a prerequisite, especially if you're just getting started. But as you want to swap out those backend resources and connect, let's say, to MySQL instead of the default, whatever we plug into, that's the place you go and configure.
Absolutely. Great. So we've got our two apps running, port 3000 and port 3001. Let's start by going to the UI and just kind of playing around with it. So we'll bring this over here. Here's our sentiment analyzer. No, I can't say it. Okay, what should we analyze? Do you have an idea? Should we take a comment and analyze that sentence?
Yes, anyone want to throw something into the sentiment analyzer? If not, I have one ready. We'll give people some time to think while they're doing that. Tuesdays are my favorite day of the week.
Oh, wow. Hot take. I think Thursday's a solid day because, you're not like cashing in on the excitement of Friday yet, but you get a little bit of it.
Well, let's the sentiment analyzer decide if that is a positive or a neutral take.
Okay, what was it again?
Tuesday is my favorite day of the week.
Favorite day of the week. Oh, wait, US or Canadian spelling? Let's do Canadian.
Sure, we'll see if it changes.
Okay, this is going to crunch away. It's going to take about like 40 seconds because I'm just running on an M2 Mac here, and so it's not analyzing particularly quick. But that is fine. It will be done pretty soon.
Nice. It's thinking
I guess.
away. And so the beauty of our KV cache, though, is the second time if we were to give it the exact same prompt, we should see nearly instant response from the app.
Right. Okay. So we're running the inference. We're chugging along here, and we will continue to patiently wait.
For it to do this thing, the power of using GPUs becomes clear. And this is making my case as to why the Spin plugin is quite nice, because you can do this sort of local testing and enjoy the speed there. Oh,
positive sentiment. Look at that.
That's great.
Great. So now if I were to enter the same sentence, day of the week, and don't get any of the spaces wrong, we can see basically an instant response there. And so that's just grabbing the cached response. Great. So let's now look at the actual traces and kind of like start to understand that a little bit. So we'll come into Jaeger. There's this concept of service in Jaeger, which is like all the different places that could be emitting the telemetry data. In our case, we want to be searching under Spin. We're happy to look for any kind of operation. Let's look just in the past 30 minutes, and we're okay with 20 results and find traces. Great. So here we can see a number of traces. This plot is kind of showing like, hey, here's time on the x-axis, and here's like the duration of the request on the y-axis. And then the size of the dot is like how many spans are in there. So a small dot has like one span, and a big dot has like 20 spans. And that's kind of just an idea of how much is going on in each request.
I see. That's a nice visual representation of, the magnitude of the amount of work getting done by any one of those.
Totally. And just hoping to help people along, because I definitely spent a long time wondering why dots were different sizes. So Okay, so we've got, I guess the best one to show. So this is going to be, we can immediately tell from the like 45-second duration that this is the call to where we actually had to do the inference. And so this is kind of a lot to understand at first, but when we break it down, it's like pretty interesting and makes a lot of sense. Um, so we first have a post to the API. And so this is the post to the sentiment analysis component API. So if we crack this open, we can see, oh, okay, so we're getting, a post to this. It returned a 200 status code. Here's all the kind of, the path that was called, all the sort of interesting things that you might want to understand when you're debugging these kind of things. And then we can see, it's calling things under it. It's kind of hard to see like that the parent that the ones under the parents are smaller because it's so long when it takes 45 seconds. But if we were to like mega zoom in, I wonder if I can zoom in enough. Whoop. Yeah, well,
nice.
just barely. You can just barely see that the executing the WebAssembly takes less time than the handling the post request. But so, in the spin app, we then execute the sentiment analysis WASM component. And this is getting a key value store. It's making a GET request to see if the cached response was there. It's not. So instead, we're using remote inference. And then this remote inference under the hood is making a post request to the other cloud GPU app we were running. Then we're executing the Fermyon Cloud GPU WebAssembly component. There, we're also doing a level of caching. This is get from env. This is checking the auth token, grabbing the foobar from the environment. And then it's doing a local inference, which is, of course, taking like 51 seconds, taking a hot minute, as you might say. And then we're setting, let me zoom out here. Right at the end here, we're setting the value. I'll pause there, though, see if there's any questions.
Yeah, any questions in the chat? This is a great breakdown, though. We can see exactly what's taking the most time. Like if we were getting feedback from our users about latency with this current application, pretty easy to take a look and immediately understand what's taking the most time in this order of operations.
Totally. Well, and so a typical example of how you might use this to like kind of debug a system is let's say, this represents a lot of requests you're getting to your system, and you come in and you look, it's like, oh, why is this one up here? why is one taking, 100 times longer than all of the other things? And so then you go in and you're like, oh, why is my inference taking 50 seconds? And in this case, it's because it's on a local machine. But imagine maybe there's some bug in the LLM implementation that's causing it to loop and take forever. Then you'd be able to be like, oh, well, this is, the really slow part. And you could like come in here and look at a flame graph and be like, oh, okay, well, feed prompt is taking the majority of this time. So I should go in there and debug what's going on, et cetera, et cetera.
And I want to rewind a little bit to a part you said where you were talking about a WASM component. And I didn't remember you ever really explicitly creating a WASM component. Could you explain where that came from in the workflow we just walked through?
That's fantastic. That is the magic of Spin, that you just sort of get it out of the box. So that WebAssembly component is really coming from me running, let me go to this app, Spin build. And so, right, you have your spin.toml, and you've got your source code. And then when you run spin build, it's taking in that source code and your toml, your manifest, and it's saying, okay, I know how to compile this out onto WebAssembly and pack this up into a component. And then spin up is really just saying, hey world, I'm ready to receive HTTP requests. And when you do, I'm going to route them to components, WebAssembly components, and I'm going to execute those components for you.
Nice. So basically every time you're running that build, you're actually creating WebAssembly components. Like it's as easy as going through our 3-step workflow for building and running applications.
Totally. I think we can just kind of briefly show as an example how the cached response is much shorter. You can see the request comes in, we execute the component, we get the key value store, and we get the value, and oh, poof, look at that. We don't need to do any inference. We respond right away. And I also want to show, this is really interesting to me, this kind of black line. This is tracing like the critical path, they call it, through a workflow. Right, so you're in this post, and then the critical path comes into the execution of the WebAssembly, then it goes into getting the key value store, then it goes into getting the value, et cetera, et cetera. So it kind of lets you trace through a request what's going on.
Oh, nice. Yeah, you can see the end-to-end journey there. That's definitely a nice feature in the UI.
Awesome. Okay, so let's just jump to do another little example. Make sure we got our two apps running. Now we're going to just do a call from a client. And so I wish this wasn't cutting off. I don't know why it's cutting off, but I'll just explain the majority of this command. Basically, we're using this tool called Otel CLI, which lets us make like client calls that also emit the spans to the same collector. So basically, this is just pretending to act as like a client in our service architecture here so that we can have multiple different services talking to each other. So we'll see this running. This is just directly calling the sentiment analysis API. And we can see it's running here. I would like that with some random text in the front to make sure that it wasn't cached, which is no longer relevant, but that's fine. And we will patiently wait again and go back to Jaeger and excitedly wait for more traces to look at.
Okay, so with this demo, we're simplifying the workflow and removing any complications that might have come from the UI, and we're just calling the API directly. We're mocking up a client and calling the API directly to understand what's going on there.
Right, and I was ignoring it for now, but really all of these kind of random ones down here, these are actually just gets from the UI. So it's like trying to get, let's see, this is getting dynamic.js. It's basically like these are the fetches to the file server for the UI elements kind of thing. So once this finishes, we should expect to see only the trace from this one. And perfect, finished. Here we go. Well, and let me just demonstrate the cached version too. Perfect, so that's cached. Boop, there we go. So here it is, and we can see a different color now because this is coming from a different service. So this OTL CLI is generating this request coming into this post API now. And, you know, remember how we talked about this context propagation? This propagation is happening here. This client is putting a trace ID in the header that is being propagated in and pulling out here and then used as like the kind of trace context. And actually that's happening at this boundary too, because we're going over an outbound request and that's propagating the trace context again. I was going to respond to the question you had on screen here. And yes, like fake traffic is a great kind of example of what this is. And yeah, Bombardier is a great tool. I love that for load gen.
And we actually do have an example out there. I'll find it on SpinUp Hub on how to load test your Spin applications. So if that's something of interest, I'll find that resource for you.
Totally. Again, we'll just kind of demonstrate the difference here of the cache to see how much quicker that is. Awesome. The last thing we kind of wanted to demo was what it looks like for errors in the code. So if I open up, let's do here, and we're going to say that instead of, well, actually, let's put the error in the Fermyon Cloud GPU app. So if I open code, source, index, and then let's just pretend, for the sake of simulating an error, that in inference, nope, it's just going to blow up. So we're going to say return, how do I do this again? Status 500.
Okay, and again, to break the stage, we're simulating an error if there's something going on with our inferencing service there.
So we will spin build that again. Remember, we're building this into a WebAssembly component. Then we will rerun this app. And let's go to here. And we're just going to change the analysis.json file. I like Wednesday. I've struggled to spell Wednesday as a child.
Understandable. It's one of those sneaky ones.
Great. So it blows up as we expect because we're calling the sentiment analysis app, which is calling the cloud GPU app, which is failing because we're returning an error. And so now we should see a failed trace. Perfect. We see the little red dot there. And we can see here, oh, we come into the trace, we're like, oh, why did it fail? Oh, interesting, there's this little red exclamation mark here. It's like, okay, let's understand what's going on there. Well, so we made an inference. Oh, there was an error. Okay, does there an error code? Failed to deserialize response for post. Okay, maybe the post is doing something wrong. Let's go look at that. Okay, we see the post. It's returning 500. Okay, that would kind of indicate to me I need to go look at the like server logs and see what's going wrong there. In this case, the error is not particularly descriptive in here because we're not returning a specific error code in the example we created, right? But you could imagine if we're returning some sort of body that's like the error code here, that would show in the tracing data. But really, it kind of gives you this idea. Instead of just like, oh, my client failed, where do I even begin? You can come to look in the trace and be like, oh, the error is happening all the way down in here. Let's go start looking there.
Yep, it definitely cuts down in time to find root cause by having this nice end-to-end view of the entire workflow of that app.
Totally.
Which is useful when you're, I guess in both cases, when you're running your application on your own infrastructure or on serverless platforms too, like understanding exactly where it fails can help cut down on is there something going on with my application or is it the services it's running on and dependent on, which can be painful to separate out at times if you don't have proper tracing and logging set up.
Absolutely. Unless there's other things people want us to show or if you have more ideas, Kenzie, I think that's pretty much our demo.
All right. Sounds like it's time to make a journey back to pitch. Thanks for walking us through all of that. Really excited to see what's possible in 2.4. We covered just a small piece of the observability pie, though. Like looking ahead, like what are some things top of mind that you would like to see support for?
Totally. 2.5, like I said earlier, is landing kind of more robust support for tracing, where we're really trying to trace all the kind of important parts of Spin, whereas we just had a few of the parts traced for Spin 2.4. So I'm really excited about that coming and landing. But there's a number of things we haven't even started working on yet that I'm excited to start working on or excited to help the community kind of dig in and contribute upstream to if they're interested in that. And the first of that is really just metrics, that other Otel signal. We'd love to be able to start emitting metrics like request count or error count or, gauges of request duration and things like that kind of let you better observe what's going on in an aggregate level in your Spin app. And then logs, we already support emitting logs from Spin, but I think it'd be really interesting to be able to tie that into Otel so that you're not just able to kind of like view the logs in process or in Fermion Cloud, but you're able to ship them off to wherever you're doing the rest of your observability work, which would be fantastic, I think. And then, traces for triggers here. There's a number of kind of like triggers and pieces of functionality for Spin that live out of tree, meaning like not in our main repo. And we don't have any tracing around those yet. And so there'll be a SIP landing soon that kind of like outlines how we want to do tracing in Spin. And, whether it's us at Fermion doing that or the maintainers of these things who own those projects or other people interested in getting involved, we'd love to see kind of tracing come to all the different parts of Spin, even that aren't in the main project. And, it's not on here. I want to talk about WASI Observe, but I'd love for Kenzie to talk for a second about, the community. We love feedback on what people would like to see.
Yes, and to just drill a little bit into that last point, SIP, for those who might not be familiar, is, I believe, a Spin improvement proposal.
Correct.
With that, my acronym game is strong today. And yeah, there are a lot out there. You can just check inside of the Spin repo on GitHub, but it goes through and explains like the why and the how for some of the larger projects we pick up. Like there's one for key value support, and so as Caleb was sharing, there'll be one for how we want to instrument traces for other components of Spin that are created upstream. So anyway, deep dive on SIP. Moving on to what you would like to see. Yeah, like creating issues, attending our community calls. We'd love to hear what's top of mind for you and what would help you feel more successful building and running Spin applications and understanding the behavior that you're seeing. So love to see that, and I'll share some links on how you can get involved with all of those resources.
Totally. I alluded to something. I said WASI Observe. So pulling the curtain back a little bit, Spin is acting as a host that's running these kind of like guests, is what we call them, guest WebAssembly modules, your Spin apps. And so the sort of tracing and observability support that we've added is kind of this like host level observability. Here's what's going on in Spin. This app was called in Spin. This many requests were made, like these kind of things. But we don't yet support in Spin or really anywhere in the WebAssembly ecosystem this concept of like guest observability, where you have your actual guest code that's running on Spin emitting observability, where you can directly choose, I want to trace this exact function. And so that's like supported out of the box, if you're doing just like running a regular TypeScript process somewhere. But we'd love to bring that support to the WebAssembly ecosystem. And so the way we're trying to do that is there's an upstream standard that we're working on called WASI Observe that I'm involved in. A number of people from other companies are involved in. And we're really trying to just build a standard for how we can do guest level observability. So still super early days, but I just thought that'd be a cool thing to share and I kind of look forward to in the future as we work to getting that guest observability working.
And if you're someone who's interested in kind of the nitty gritty of the upstream work, like where would you recommend someone getting started to like learn more and then also to get involved in the community?
That's a great question. If you want to get involved, I think it's on the GitHub repo and there's like links to where you can get involved. You just need to email Chris and you can start joining the meetings and kind of following along with that. If you just want to like kind of get immersed in all this stuff going in upstream WebAssembly, I would highly recommend checking out the Zulip, which I can try and find a link to. The Zulip is like this online chat platform for where basically all the people working on upstream WebAssembly chat about stuff. So that's a great place to like snoop and learn about all this stuff. I do that sometimes because there's some really smart people there. But that's maybe the two places I'd recommend, or even just on Spin, like getting involved in understanding how kind of Spin does stuff first is a great place to get started with all that upstream work.
Yeah, exactly. I guess I took us to the deep end of the pool, but it's really interesting to see, how those efforts are going there, and we're pulling them into Spin, and then also presenting them to you in forums like today in Live Coding Tuesdays.
Totally.
All right. And so this is along the same lines of what we were chatting about on how to get involved. So this is a link to our Discord community, and then our GitHub repo, and then we shared earlier, but WASI Observe, if you want to go upstream and want to learn a little bit about the work going on there, that's another great resource to check out as well. All right. Well, if there aren't any questions, I think we are out of content and time for today. So thank you so much, Caleb, for hopping on and chatting with me today.
It's been such a pleasure. I'll have to come back.
We would love that. And thank you to all the viewers for tuning in, asking your questions, and participating. It's fantastic to hear from you, and looking forward to seeing you on the next Live Coding Tuesday. All right. Bye, everyone.